continue our discussion on VM migration. So, last lecture what we discussed is that what are the need of VM migration and why it is important and what are the different way or mechanisms to do that, right. Today, we will try to see little bit of analysis of that how to do some sort of a mathematical model or how to approach those problem in today's lecture, right. So, today we will do some VM migration analysis and also we will be looking at the strategies. So, these are the keywords. So, just to quick recap. So, it is a when we talk about migration is a process of to move some running application or VMs from one physical server or host to another physical server, right. So, process state, storage, memory, network connection, if there is active IO, those as needs to be taken care of. As we discussed in the last class, so if we look at that say the process state or sometimes we refer as a CPU state is a important factor which need to be taken care. Memory, that means the where the VM or the is working on, that is the active memory or the main memory which need to be migrated, and of course, in some of the cases networking, because not some of the cases networking is important, because now the your if you see the your connectivity is not longer in the in that VM, it is somewhere here. So, some sort of a mapping of this IP to MAC and things like that has to be looked into, right, or some sort of a ARP related issues need to be resolved, and in some cases if there are active IOs, so that need to be looked into. So, that last class we discussed, right. And also why to migrate, that is one of the major reason is that if there is load balancing and system maintenance. We discussed few of the things, some may be the same thing, but in maybe little there may be wording difference. So, one definitely is load balancing, right. So, when the load is considerably unbalanced, like if you have host where unbalanced loads and impending downtime often require migration of VMs, right. So, in order to have a more faithful service by the provider, this migration is one of the things which we may look into. Other things what we looked at as the power fault tolerant, right. So, is another challenge to guarantee critical service availability and reliability, right. Failure should be anticipated and proactively handled, rather in some of the reference you will find that what we say proactive fault tolerance. So, we if there is failure, then need to be proactively handled, right. Power management. So, switching the idle mode server to either sleep mode. So, the server which are idle mode or less loaded sleep mode or off mode based on the resource demands, right, that leads to energy savings. VM live migration is a good technique of doing that. So, overall energy requirement of the particular data center need to be looked into, where we can look into the idle server, where the server having very less number of VMs that can be migrated to other servers, and some of the servers can be made free, so that they can go for a sleep mode or sometimes in a off mode, that means they will consume less power than expected while it is in a running mode, right. Resource sharing, challenge of limited hardware resources like memory, cache, CPU, this cycles can be resolved by relocating VMs over from overloaded servers to the underloaded server. So, that is other way around. So, if there is a lot of crunch, that it basically goes on a some sort of a load balancing sort of things, but here the major challenge is that resource sharing. So, if we need, in some cases you require that these are the say CPU hungry operations. So, those may be shifted to some of the things which has more resources on that front and type of this, right. So, there is a resource sharing. Of course, last but not the least, rather one of the major requirement is the system maintenance, right. So, a service provider putting shutting down the system and or taking downtime for a long time is always a negative point, right, that affects its credibility and revenue as well, right. So, physical system required to be sometimes upgraded, goes for a system maintenance, and so the VMs in that physical system must be migrated to alternate server, so that the service downtime is minimized, or you can be provided uninterrupted services. So, these things we have looked into or seen these scenarios, right. So, these are the major things which we require when it is migrating, and also we looked into two major way aspect, that is, one is pre-copy approach, another is post-copy approach, and just we have a quick little bit more in depth into the thing. So, whatever we are talking about is live migration scenarios, right. So, uses iterative push phase, that is followed by a stop and copy phase in this live pre-copy approach. Because of iterative procedure, some memory pages have been modified or updated or modified, what we refer as a dirty pages, right. When it is going on transferring, this page can be modified at the other end. So, if you dirty pages are regenerated on the source server during the migration iteration. So, when the migration iteration going on, these pages can be at the source can be modified or updated, and that creates these dirty pages. So, these dirty pages had to be resent to the destination host in a future iteration, right. If there is a dirty page, so it need to be sent to the things. Hence, some of the frequently accessed memory pages are sent several times. So, what we see that some of these memory pages are sent several times, it causes a long migration time, because it is once there is a dirty page and things like that. If you remember, we called about that when the dirty pages are below a threshold, or ideally there is no dirty page, then we say that the whole thing has been migrated properly. So, if we look at the first phase or the first step towards this pre-copy migration, is the all pages are transferred while the VM running continuously on the source host, right. Further rounds dirty pages are resent, right. So, what we see that all in the step 1, all pages are transferred while the VM still running on the source host. So, automatic source host. So, automatically there may be updation of the pages. So, these dirty pages are resent, right. So, second step is termination phase, which depends on the defined threshold, right, at where you terminate this and put the CPU state on the other thing, and then start working on the things, right. So, the termination is executed if any one out of these three conditions we seen earlier also. The number of iteration exceeds the predefined number of iterations, right. I look for say n number of iteration and it goes on more than the defined. So, that is what we say that it is crossing in max type of things. The total amount of memory that has been sent is above a threshold, or the number of dirty pages is just previous round fall below a defined threshold. So, if the dirty pages fall below a defined threshold, then we stop this step 2 of the pre-copy approach, the second phase of the things. And in the last stop and copy phase, migrating VM is suspended at source server. After that, move the processor state and remaining dirty pages to the destination server, and then start working on the this VM is initiated or started at the destination server. So, when the VM migration process is completed in the correct way, that means all these steps are there, then what we do, then the hypervisor resumes the migrant VM on the destination server. So, the hypervisor resumes those migrating VM on the destination server, right. So, if you look at KVM, Xen, VMware, hypervisor use this pre-copy technique, right, this pre-copy approach for live VM migration. This our popular hypervisor like KVM, Xen, VMware, these hypervisors, they use this pre-copy approach. So, this is in the pictorial form. If we see in the flow chart form, which is given in this reference, this is a nice survey paper which you can refer. Migration, so start of migration. So, destination server selection, that where is the destination server, resource reservation as the destination site is important because the VM will be there. So, the resource should be available. Capture the whole memory and assume it as a DATI. So, whole memory is transferred there. Iteratively copy the DATI memory pages of the VM to the destination server, right. So, initially the whole is copied and then as and when incremental things are going on there. So, stop and copy, if it is still not below that threshold, this first that iteration goes on. If it is there, suspend the VM and transfer the VM state, that CPU, register, VM memory and so forth, that state of the VM to the destination server, right. So, resume VM at the destination server and start working on the things, right. By the hypervisor resumes the VM at the destination server and the whole migration process is done or committed, right. So, this is nicely given this flow chart where initially that whole memory is being transferred, then iteratively copying the DATI memory and this iteratively from the source to the destinations, one that is there within the above the threshold, then we suspend and go on continuing with the destination server. The other one is the post copy phase. In the post copy migration, the processor state transfer before the memory content and then VM could be started at the destination server, right. So, post copy migration technique investigate demand paging, active push and pre-paging. There are other techniques also for pre-fetching of the memory pages at the destination server. So, as we say stop phase, stop the source VM and copy the CPU state to the destination, restart the destination phase, on demand copies for the on demand means copy approach, copy the VM memory according to the demand of the things, right. So, this is the what we look at the post copy approach, right. So, if we try to look at the same thing in the flow chart format. So, the migration starts, right, destination server selection, that with destination, resource allocation at the destination site, right, capture VM state like CPU registered, if there are any IO state and type of things, transfer the VM state to the destination server, transfer VM minimum state to the destination server and then resume the VM at the destination server, right. And active push DATI memory pages of the VM to the from the source to the destination server, right. So, initially whole memory is pushed into the things. If there is a page fault, yes, the copy the fully faulty pages from the source server, right. If it is no, all memory pages of the VM transferred successfully, if yes, migration ends. So, it is somewhat what we say post copying of the memory from the source to the destination server. So, these are two approaches what we try to look at. So, the major challenge is definitely this memory thing, like if at it is getting DATI pages and how many iterations goes on and things like that, it is a challenge and need to be looked into that need to be looked into the whole process to be completed and committed, as the whole state is transferred into the things, right. So, let us do some analysis for the things. So, this is with reference with some of the literatures and also done one of my ex postdoc researcher Dr. Saurabh, who is presently at NIT Surathkal. So, let TMIG be the total migration time, right. So, if we consider the total migration time as the T MIG, let T down be the total downtime, right. And so, for non-live migration of a single VM, the migration time T MIG can be VM by R. So, VM is the size of the memory, right, or the memory size, and R is the transmission rate. So, what we are considering, that transmission rate remains constant throughout the migration process. So, the transmission rate throughout the migration process, right. So, that is one assumption, and that may be a fair assumption, because taking a something average migration rate or transmission rate, and with the type of connectivity, etcetera, that is the assumption, right. So, what we say T MIG migration time is the whole memory migration divided by R, right. So, this is the typical migration time. So, as we see that the memory is the major constraint of migrating, right. Other things is a one time things, you shut down CPU and go on. So, this is the major constraint. So, rather in non-live migration, practically the downtime is same as the more or less same as the migration time, right. There are other considerations like CPU state transfer, etcetera, but practically downtime is the dictated by the migration T MIG migration of this memory, right. So, in other sense, if this is a non-live migration, what we say that T down is more or less or basically equal to the T MIG, right. So, this is the what we see if we have a when we have a non-live migration type of scenarios. Okay. Now, let n be the total number of iteration in the pre-copy phrase. Now, we are considering pre-copy live migration in a pre-copy cycle or pre-copy approach, right. So, let n be the total number of iterations what we are looking for, right. So, so much iteration is required, and T I j represent the total time that jth iterative transmit or jth iteration transmit ith virtual machine's memory. So, V T I j. So, the ith virtual machine in the jth iteration the memory is transferred. So, VM is the memory of the VM, as we have seen. VTH is the threshold for stopping the iteration, right, when this is the maximum need to be transferred. N max is the maximum number of iteration which is allowed, that is another threshold. So, VTH or N max is dictates the threshold of the things, and R because we have this page size and the dirty page and the transmission rate. So, R basically is the factor which dictates this controls this how much any iterations and how much this dirty paging things rate is there, right. So, P, that is means the page size into dirty page divided by transmission rate R is dictates that this you can think of that this sort of a factor which tells that the rate of this dirty paging, right. So, T res denote the time taken to restart the VM on the destination server, right. So, it is the time taken at the to restart the VM at the destination server. So, pre-copy migration mechanism, the VM memory can be migrated iteratively or rather are migrated iteratively. We can compute the total migration time TIMG of the ith VM as follows, right, if there are ith VM. So, TIMG is equal to summation of j 0 to n Tij V equal to VM by R 1 minus R to the power n plus 1 by 1 minus R plus T res, right. So, where it take as we told T res is the time taken to restart the VM at the destination server, and T down is represented by this component R to the power n VM by R plus T res, right. So, some just to do some calculation like in the T 0 VM by R, whatever the memory was there, it is in the R, where in the T 1 we have the dirty paging thing. So, based on the if that is my base time, so it is P into d by r into T 0 and rest of the calculation comes from there. And similarly, if T 2 p into d by r, that is the factor what we calculated at a small r into T 1 and T 3 is like that and so forth. So, when we have round T n minus 1, so r to the power n minus 1 V m by r, right. So, through this analogy, and the round n where we stop the memory copying, stop this phase or what we say that step 1, step 2 and copy the things. So, T n is given represented by r to the power n V m by r, right. So, if the total time we calculate and V m by r 1 minus r n plus 1 by 1 minus r, which is basically represented out here, right, plus the time taken for there, right. So, there may be little simplistic or some assumptions are there. First of all, this rate of transmission, these are constant and we are considering that few factors like within this threshold it is working and type of things, right. But nevertheless, it gives us a idea that how overall that how much time or how much migration time may be required, things like that, right. Why this is important? This is important because we need to plan for it, right. Migration is if it is a due to maintenance etcetera, then we need to system maintenance and we are migrating with a predefined things like we will migrate on so and so date at so and so time, then we have to predefine that how much time will take, then it will again active VM will be active, accordingly consumer need to be initiated. If there is a certainly due to some fault or something need to be migrated, that also we need to know that how much time it requires for migrating the things. So, this is important to have a estimate of the things how is to be there. Things will become little complicated when we talk about this I/O and other type of things, especially the network level migration, all those things like where your connectivity need to be repositioned and things like that. Okay. So, that may become little complicated, but nevertheless it gives you a broad idea that how things works, right. So, there is another things, we are not going much nitty-gritty into the things that there is a need of estimating the number of rounds, right, is required for the things, right, considering there is a threshold for the VM memory, right, and also there is a in max that how much we can go, right. So, we need to look at that how much memory is there, which is threshold by the VM with a R is again coming as the factor of the dirty paging, dirty page where we calculated, and based on that we can find, we can see that it is the min of, because whichever is minimum, that n max or this calculating VTH by VM log of R of looking at that factor, that is number of rounds. Again there may be little gross estimation, in reality there will be different other factors which you need to be considered, but not but it is a give a ballpark things that how can be migrated. Now, where there is when we migrate multiple VMs, right. So, when we migrate need to migrate multiple VMs, as we seen that these are we considered that ith VMs and things like that. Then when we migrate multiple VMs, generally to approach. So, generally multiple, because when you are going for a system maintenance, it is not like that one VM to be migrated. There may be a special case, there may be a some resource requirement where the VM what you are working on is not possible to run on this particular server or the host, and because of the requirement rise in the requirement, the VM need to be migrated to something, so that you have a better resources to cater to the customer. So, there may be reasons like that, but in most of the in other cases where you go for a system maintenance or you are expecting or detected a fault and want to recover the transfer this VM to another thing. So, it is not one VM, rather is multiple VMs which need to be transferred to the destination host. Now, typical strategies as intuitively come as one is going serially, right, one VM, then next VM, next VM and type of things. That is something one at a time, which maybe if we consider that looking at the other our calculation that a single VM multiple times, right, it can be there, or there can be a parallel migration. So, I migrate the whole thing in a parallel and it goes in a migrating way. So, when you look at the serial migration, so the first VM that is selected to be migrated executes its pre-copy cycle and other m-1 VMs continue to provide services, that is there, right. So, I have say m VMs and then the first VM gets migrated using this say pre-copy cycle and type of things, and then the rest of the VMs which are n-1 they continue to give services. As soon as the first VM enters into the stop and copy phase, the remaining m-VMs are suspended and copied to the first VM completes its stop and copy phase until it this. So, the once it is P and copy, the other are suspended and then that executes this first VM executes its completes its copy phase. Reason for stopping the m-1 VM is to stop those VMs from dirtying the memory, right. Otherwise, what will happen during this portion, what is, if it is a single bin, what is expecting that nobody is dirtying this memory, right. Once it is stop and copy phase, we expect that no one is dirtying this memory, because there is a single VM which was dirtying and now once I stop that thing, it is not dirtying the memory, right. But in this case, it may so happen the other VMs may dirtying the memory, right. So, one assumption that each VM that is copied at a full transmission rate, right. So, the full transmission rate is available as we have seen that R. The downtime for serial migration includes the stop copy phase of the first VM, the migration time for the m-VM and time to resume the VMs at the destination VM. So, that is those type of things are considered if we consider that this type of serial thing. So, one when we look at the parallel migration, so the major difference what we can see that all m VMs start their pre-copy cycle simultaneously. It is a big challenge, right. So, all these m VMs because it is parallel. So, each VM effectively we can consider get a rate of r minus m for the transmission capacity, right, or actually there will be few more overheads. So, it is effectively less, but we can consider that r by m type of bandwidth they are getting or transmission capacity they are getting to transmit the that VM I VM1 to VM m to the destination, right. So, here all we are considering that it is transfer from one host or one server to another server on the other host or other server, right. So, as the VM sizes as the VM sizes are same and transmission rates are same. So, that is another consideration same the VM begins to stop copy phase more or less at the same time and they end the copy phase also at the same time. So, it is little maybe I should not say strong assumption, but we also assume that all VMs are of the same size. So, ideally they are having the same transmission rate and more or less though they are serving different things. So, they are other iterations stop copy phase will be at the same time, right. Since the stop copy phase is executed in parallel, they consume the same amount of time at the downtime is in fact equivalent to the time taken by stop copy phase for any VM added to the time taken to the resume the VM at the things, right. So, as the if we look at the real downtime, what it is happening is basically that because so long this memory is being copying, the VM is active at the source end, right. So, when you have a stop copy phase, that time the downtime is being activated, right. So, as we are considering that those are all in the same time. So, so it is being the downtime in addition that the time it take to resume the operation at the destination VM, right. So, in case of a parallel things, but nevertheless the effective transmission rate it got each VM have is something which is R by M, right, effective transmission rate. So, that is the another that need to be considered. So, if we look at today's discussion, so what we try to do some means a broad analysis, or try to look at that what will be some estimation of this our sort of a this migration time and downtime sort of things, and also as that estimation of this how much iterations required based on the this dirty paging phenomena. And also we try to see or have a overview of this what is when we have multiple VMs, more than one VMs into the things, or whether this parallel migration or vis-a-vis a serial migration, how things are carried out, right. So, with this let us stop our discussion for today's discussion, and we will continue with other aspects of this our this cloud computing in our subsequent classes. Thank you.